Trees in every country. Trees, you know we can work together and learn what we need to meet the challenge.
Hello and welcome to the Conference Rewind video series. My name is Avery Lewis, editorial and publishing specialist with the International Society of Arboriculture. Today, we are excited to bring you a presentation by Dr. Tom Smiley, Dr. Richard Howard, Ryan Gilpin, and Nelda Matheny, focusing on the ISA Best Management Practices for Construction Near Trees. This presentation was originally given at the 2021 ISA Virtual Conference, and the views are those of the presenters. So if you're interested in construction near trees or the impact construction has on trees, I think you'll like this video. Now sit back and enjoy.
Welcome to today's presentation on managing trees during construction. First off, there are a number of construction trends that may be of interest to arborists. First off is that single-family home construction rates are increasing. This is very similar to the multifamily homes and commercial development rates. And I'll come back to this in just a minute to show you the trend. The core area construction that's going on now tends to be predominated by infill. That is additional dwelling units, the conversion of single to multi-family homes, or complete home replacement. And more construction is occurring in the outer suburbs, and there's less increase in the core areas. And this gives arborists some great opportunities, especially if you're just getting into the business of managing trees during construction. Well, here's the trend, and this graph starts in 1968 and continues to the end of last year. And you can see the lines have gone up and down. We were on a good trend from 1990 until the recession hit in 2007, a big drop off, and now we're basically paralleling the direction before. Big fluctuations with COVID here, but the trend tends to be upward. For single family houses, there are over 1 million housing starts per month in the United States. Not as many multifamily or commercial, where we actually tend to do more work, but a lot of home construction is happening out there. Well, why are we concerned with trees on construction sites? With climate change and tree loss from fires, especially in the West, urban trees certainly have an increased importance in doing things like sequestering carbon. They also provide health and aesthetic benefits to their owners and to the community as a whole. They provide wildlife habitat. This is especially important in the city. They can increase home and business values. We see more business in downtown areas that do have treed streets. They can reduce heating and cooling costs. Cooling costs, they can provide shade, and heating costs can be reduced with the windbreaking effect of trees in the winter. And it is trees over 12 inches in diameter that provide the most benefits and are generally considered carbon negative. Carbon negative meaning that they bring in more carbon than it takes to maintain them. So up to that 12-inch or round about 12 inches, the carbon has been at a deficit. It's taken more carbon to get the tree there than it has sequestered in the tree. But after 12 inches, we are gaining carbon sequestration. And also, especially important during construction, is that some plant species or trees in certain locations can cause damage to houses and decrease house values. So this is something that we can help developers with. So the arborists can work with the development team, and doing so increases the rate of tree survival. We can also assist tree removal decisions, and that can reduce future costs. It's much easier to remove a tree without a house underneath it than if we have to remove it after the house has been built and the tree has to be removed. So making those decisions early can help out the developer or the homeowner. And in some areas, working with arborists is required by ordinance. Well, where do we start with trees and development? Probably the best place in the United States is with the ANSI A300 Part 5. This is the third revision of Part 5. It's been around for a long time, 15 years. The first version coming out in 2005, and the current version was published in 2019. The purpose of this standard is to provide guidelines for management of trees and shrubs during development and to provide standards for writing specifications. And in addition to the standards, the ISA publishes best management practices. They were developed to interpret tree care standards and to provide guidelines for practice, guidelines of practice for arborists. We have a wide array of these BMPs. Basically, every area of tree care has a standard and a BMP associated with it. And the BMPs are very inexpensive, so you can share them with arborists, share them with crews, or even clients. With the A300 standard, there are three major components. First is a definition of the purpose, objectives, and the scope of work. We're going to talk about the first two as I get going, and then later on in this group presentation, I'm going to come back to the scope of work. So the second component of Part 5 go over the phases of a construction project and how arborists should be involved. And this is followed by a section on practices. We have two major groups here. One is with the definition and determination of tree protection zones, and you'll see that abbreviated in this presentation as TPZ, what type of barriers we should use. And the other major area of practices is techniques to minimize tree damage. And this is basically the outline of this group presentation today. So the ANSI standard says that tree management and arborist involvement should be in all phases of development. We know that we have much better outcomes if the arborist is involved from the beginning of the project through the very end, and hopefully even carrying over into maintenance of the trees as time goes on. But again, as with all standards, this standard calls for the definition of objectives. And in this case, objectives should include complying with local regulations for development, protecting trees to reduce loss both during construction and after construction, and minimizing conflicts with infrastructure. There are additional objectives that you can consider, but these are the main ones that we look at. Well, with that, let me do some introductions. First off, I am Tom Smiley. I'm at the Bartlett Tree Research Laboratory. I now live in Washington State. I am a member of the A300 committee, and I am co-author of the ISA's Construction Best Management Practice. Coming up next is Ryan Gilpin. He is the principal consultant at Nidus Consulting in Portland, Portland, Oregon, and he is the co-author of ISA's Construction BMP. He'll be speaking on arborist involvement in all the phases of construction. He'll be followed by Nelda Matheny. She is the founder of Hort Science Consulting in Pleasanton, California, and she has recently retired from Bartlett Consulting Hort Science. She is a co-author of ISA's Construction BMP and many other books, including Trees and Development, which she and Jim Clark are working hard to get updated. She will be speaking on tree protection zones. And last but not least is Dr. Rich Hout from the University of Wisconsin at Stevens Point. He is a member of the ANSI A300 committee and co-author of the ISA's Construction BMP. He's conducted many research projects looking at tree survival near construction sites. He'll be speaking on root cutting and its impact on tree health and stability. So next up is Ryan Gilpin speaking on phases of construction and arborist involvement.
Thanks, Tom. So I'm going to tell all of you a little bit about how I see arborists involved on construction sites from my projects and how the arborist involvement changes over time and what you can expect at the different phases of the project and what your involvement might be. The first thing I want to emphasize is that arborists who come onto construction projects all of a sudden are the tree experts and start getting asked questions about how to preserve trees, about what sort of tolerance this tree has to construction impacts. And so think of yourself as a consultant. This is really a best management practice designed for consultants with a very broad definition of consultant. If you are there giving recommendations about trees, you are consulting and can rely some on our materials to help you with that. And so a couple other things that are interesting or maybe different about construction projects and our involvement with them is we're often some of the first people on site. If it's done right, like Tom said, we're involved very, very early in the project. And so being ready for this and some of the challenges associated with not having the full team together or the project totally planned, that's something that we need to be able to work with. Because we're going to be integrated into a design or construction team that's going to include engineers and architects and planners and all sorts of people. And that this is important to be able to communicate effectively with them and share data and work on plans together with them. It's a different type of skill that isn't always shown off in other types of arboriculture. So the first phase we're going to call the planning phase. And our first opportunity to show off our expertise when we are involved in the planning phase is knowledge of our local ordinances. So as Tom said, many areas have local ordinances that protect trees and have requirements about their removal or pruning or protection and different things like that. So here in Portland, Oregon, we call that Title 11. And Title 11, Chapter 11.50 is related to trees and development. So this is what we really need to be experts in. And everything that we say in the best management practices is generally true, but I'd like to emphasize that this is what's most important. If it says to do something in your local ordinance, do that. Follow these local ordinances. They are very important in the success of these projects. Then we need to figure out our project area. Where are we going to be doing our resource evaluation, generally a tree inventory? And I prefer to look at construction plans and determine my own project area and where I need to do my inventory. But that's not always available. Sometimes we're so early in a project that we may just have a general area. We may have different sorts of data that come in, sometimes just a line on a piece of paper, and we take that and do the best that we can out there. Then we move into the tree inventory phase. And I think everyone on this call is probably pretty comfortable with the main components of a tree inventory. There's a full best management practice about that. But we're going to be collecting things like identification numbers, location, species, size, and condition. But there are a couple of factors to really focus on preservation projects, trees and construction. And that's the protected status of the tree. So that local ordinance, what are going to be the requirements, which trees are protected and which ones aren't, which ones will they need a permit to remove and which ones won't they? And then the suitability for preservation. I sometimes see this used different ways. The way that we use it is that this is really data about the tree and our expertise of, is this species going to be successful on this site? Is this a species that's really desirable in this area? What do we know more about this tree than is just conveyed by the diameter and condition? Let's give us another opportunity to show off our expertise. And this is different than, is there construction near the tree and this tree is not going to survive that? This is really all about the tree and not about the construction. I highly recommend using tags on these construction site projects because the construction personnel are going to need to make decisions about the trees and they may not be able to tell them apart unless they have a tag on them. And location is so important. So one of the main problems that I see arborists have getting involved in this type of work is being able to work effectively with a surveyor. So often on these projects, a surveyor is going to accurately locate these trees and be able to plot them on the construction plans. And we need to make sure our data and those locations get lined up. And this is pretty easy to do if you do it early enough. If you work with the surveyor at the beginning of the project, very difficult to do if you forget that step and try to match them up later. So after we have our resource evaluation, we're going to move on to the design phase. That's when we start looking at construction plans, what we're going to call development plan review, where we create a tree protection plan or someone else creates a tree protection plan, and maybe we write a report or some sort of documentation about this. So let's go through these a little bit. Maybe the biggest change that we're likely going to see in these new best management practices, if you compare them from the previous version, is this focus on development plan review. And what we're really focusing on is which trees are going to survive construction and which ones won't. And so it can be difficult. This is a new skill to learn for a lot of arborists. And what we're basically doing is looking at this CAD plan or at the paper plan beneath it. And these two trees here have this sidewalk coming in. And we have to be able to visualize, this is actually that tree in those plans, that when this sidewalk comes in, they're going to excavate in this area and there's going to be root damage for that. And so we're trying to predict whether these trees are going to be able to survive that or not. And that's really a lot of our arborist expertise, but it relies on us being able to understand construction plans and imagine what's going to happen in the field. So the main way that we protect trees is through tree protection zones. And these are called different things in different areas. Portland here calls them the root protection zone. Some people talk about it as the critical root zone. I suggest you use the terminology of your local ordinance, but we're going to call them tree protection zones. And Nelda is really going to dig into this later. But generally, there's no construction allowed within this area. And then the construction crews can sort of do whatever they want out there. So we have, fencing that we suggest. We have different ways of calculating what that should be. But the biggest part of it is that we're now including construction plans in the tree protection zone designation. So we want to make sure that we can actually complete the construction that's planned and be able to protect our tree. So for example, I'll talk about that in a second. Then we want to go into some sort of reporting. So I have this arborist report here where I've documented what's going to happen, right? So how many trees are going to be removed and how are we going to protect the trees that are going to remain? And so this really has two different audiences, right? Because the city really cares about how many trees are going to be removed and whether or not they're going to approve this project. And then the construction team really cares about how are we going to protect these trees? What do we have to do during construction? Often at this point, there's a tree preservation plan made, a tree protection plan. We can call it all sorts of different things. This is one that I made, but most often my clients make them or my different project partners, the landscape architect or the civil engineer makes them and includes them in their plan set with a lot of information from us. And the most information that we add are tree preservation guidelines or tree protection measures. And this is really outlining what's allowed within that tree protection zone and what's allowed outside of that tree protection zone. And so this is really important in being able to offer our expertise and get that integrated into the construction plans and what's actually going to happen out in the field. So after the design phase is over and construction is getting ready to get going, the project's been approved, the pre-construction phase starts. And the most important part of this phase is that we get tree protection fencing up before construction begins, before anything happens on the site if we can. And typically I'm not going out and putting up any fence. I'm inspecting fence. I'm telling people where to put fence, helping them interpret the plans for that. And the most important part of that is meeting with the construction team before construction starts. So at the kickoff meeting, if the arborist is there, I find that that's so important to the success of a project, and that so often trees are injured at the very first day or first couple of days of a project. And if we can get involved early, we can avoid some of that happening. Pay attention to your local ordinances. So for example, in the city of Portland, there are strong requirements for signage on the tree protection fencing, but know what's important in your area, not just through the ordinances, but through the health of the tree. So in California, we have these hot, dry summers. We know on construction sites, there's going to be root loss and maybe some compaction. So we need to get water on these trees, and that irrigation of trees on construction projects in California is hugely important and helps their success. This is also a good opportunity to do any tree care that's needed. Most often, I see clearance pruning so that we don't damage the trees more than we have to when the equipment's working near them. But maybe this is a good time for pest management or something else that's important in your area. You'll know what those are with your local focus. Once we have our tree protection fencing up, construction is going to start. They're always very anxious to get going. And basically at this point, what we're doing is we are monitoring root loss and root damage. There's lots of other ways that we can be involved in these projects, but that's the biggest and I'd argue most important one. So what we're going to do is we're going to watch them or come after they've done an excavation and damaged roots, and we're going to assess whether the tree can survive the level of root loss that it experienced. And we can help make sure that all these roots are cut as cleanly as possible. And if we're there on site when it's happening, we can make sure that they're cut before they're broken and things like that. That can be really important roles for us to be as an arborist on a construction site. There's lots of other damage that can happen. So I see trunk damage. I see very often those branches ripped off where they should have been pruned for clearance before the construction crews came in. And we have very little we can do to sort of mitigate this. We can do a little bit of pruning, a little bit of other options. We really need to try to stop this from happening before it happens. And that's really by setting up our fencing and by making sure everyone understands we're not going to go in there. And if you do need to go in there, you're going to have your arborist on site with you so that we can monitor the root loss and provide recommendations on how to avoid cutting roots if at all possible. We're really trying to avoid this when we're doing our plan review. And so I showed earlier a little shot of a water line going right in between a couple of trees. And what we'd like to do is identify during the design phase, hey, there's construction happening in our tree protection zone. We need to do something about that. Because what happens when we get to this phase, we have very few options to make any changes, and we end up losing a lot of trees in this situation where we could have identified them earlier. So focus on the plan review portion of the plan, of the design phase so that we can try to avoid this happening and minimize our tree loss on construction sites that was avoidable if we had identified it earlier. In California, we're going to want to measure our soil moisture, monitor that throughout the summer, advise increasing irrigation, things like that. And we can only do these things and only be effective if we have good relationships with our construction crews and be able to work well with them and be part of that team. Towards the end of the project, they start taking down fences, start planting, start wanting to really enjoy this site again, right? So I'd like to emphasize that this is a key time to be involved and try to advise your clients to have you out there, where a lot of damage can happen during planting in the tree protection zone just after the fences come down. This is really a key time to be out there monitoring, educating crews and working with them to ensure that we're continuing to protect these trees. And then often what I see at the end of construction projects is some sort of requirement where we want to reassess the trees, reevaluate their health. We want some sort of final sign off that the companies followed, the construction crews followed the tree preservation requirements, things like that. So often we're involved, and we were both the first ones on site and now we're the very last ones on site where people are about to move into the buildings. They just need their final sign off. Okay, so that was a quick overview of the phases of construction and how arborists might be involved in each phase. Obviously, one of the most important things is tree protection zones. How are we going to make those and what are they going to look like? And so Nelda is going to tell us a little bit more about that.
Thank you, Ryan, for getting us started on tree protection zone. My task is to tell you about the tree protection zone and how we go about estimating where it is and how big it is and so forth. So let's get going. When we get on construction sites, it's not usually a pretty picture. If there are trees nearby, it's extremely difficult to develop those sites without doing some damage or injury to the trees that are nearby. So our role is to try to limit that amount of damage to a tolerable level. The BMP second edition defines the tree protection zone as the area defined during site development where construction activities and access are limited to protect the trees and soil from damage and to sustain tree health and stability. So this tree protection zone is what we are all trying to figure out, the space that is needed around a tree to keep it healthy and stable. And we see a lot of variability in the landscape in development sites of what the dimensions and distance of that tree protection zone is to the trunk. So where do we draw the line? How do we figure out how much space an individual tree would need to retain its health and structure? The BMP also states that the size and shape of the TPZ should consider the tree species, its response to construction impacts, its size, condition, and maturity, in addition to the location of the current infrastructure and the planned construction, and what the specific aspects of the site are. So we have a lot of considerations when we're trying to figure out what this tree protection zone is going to be. So the question is, where do we draw the line on the tree protection zone? When Jim and I were writing the Trees in Development book, it was back in 1998, we did research around the world of what were arborists using, what metrics were they using to define the tree protection zone. And there were three that were in primary use. One is the drip line, where you simply draw a line down from the edge of the canopy, and whatever's within that circular shape, semicircular shape, becomes the tree protection zone. It has some limitations in that when the tree canopy is asymmetric, we might be too close to one side of the trunk or the other. Or when we have a tall, narrow canopy, the tree protection zone may wind up being actually too small for the tree. Another common method is the trunk diameter method, which is you measure the trunk diameter and multiply it by some distance factor. In most cases, we found the distance factor to be 1 to 1.5 feet radius per inch of trunk diameter. Now, the trunk diameter seemed more reliable to us, but in our experience in preserving trees, we found that there was such a difference in species and age response to impacts. We needed to include that in our TPZ estimates. So that led us to looking at the British standard for identifying a protection area, which does consider age and species tolerance. To that, we added a particular diameter, a radius measurement based on the diameter of the tree. And we started with the transplanting standards, which are generally 6 to 12 inches of root area per inch of trunk diameter. And we considered that as suitable for a young tree with good transplant suitability. This all led to what is now in the BMP, in which we look at what is the construction tolerance of the tree, high, medium, or low, what is the relative tree age, young, mature, and over-mature, and then we have a multiplier factor, which accounts for, that we apply to the diameter of the trunk. So here's an example. We have a healthy, mature, 30-inch diameter black walnut. And if we go through the process here, we see that the species tolerance is low. I know that because I work with a lot of black walnuts. The age here is mature. It's not going to get any bigger. And so the TPZ factor is 15. So we're in low, mature, and here our factor is 15. So we multiply 15 by the diameter of the trunk, which is 30. We get 450 inches, which is 37.5 feet. So then we would plot that radius around the tree, and that would prescribe our tree protection zone. Depending on these factors of species and age, that limit might be within the drip line, it might be far outside the drip line. So this tree protection zone is independent of the canopy size. Now, we have to know what the species construction tolerance is in order to use this method. So how are we going to know that? Well, we're going to know that from our experience. And when Jim and I did the first edition of the Trees in Development book, we queried arborists around the world about what is your experience with various species in their construction tolerance. So we wound up with a list of about 250 species that are in the book. And here are some examples: high, honey locust, sycamore, green ash; medium, excuse me, spruce, tulip tree, linden; low, beech, hemlock, and black walnut. Now you'll notice 4 of these are in bold text, and that is because we got different rankings from different people living in different environments and working in different environments. So for instance, tulip tree, which I would call in our hot, dry climate in Northern California to have a low construction tolerance. However, people who are working in the area in which it's native in the Southeast US thought that it had medium to good tolerance, medium to high tolerance. So these aren't hard and fast rules. They really need to incorporate your own experience in the particular environment in which you're working. If you don't know, can't find any information on what the construction tolerance is, then the things you might think about are how well that species responds to transplanting. Is it drought tolerant? How does it respond to root pruning? How does it respond if you clear the land around it? How well does it compartmentalize decay when it's wounded? And what is its native range? Are you working within its native range or in an environment that has climate and weather similar to its native range? Now, there is a difference between what we want to consider the optimum tree protection zone versus what we might be able to get. In San Francisco Bay region, we are highly impacted by density of development. Land is expensive and we have a lot of people. So we never seem to get as much space around trees during development as we would like. Now, so what do we do about that? We're not looking at preserving optimum space. We're being pressed to determine what's the minimum space. How close can we get? Well, how close we can get depends on the species and age, of course, and the condition of the tree, how the roots are growing, where they're growing, if they've been damaged in the past, if there's decay present, what's the height of the tree and exposure to wind, which affects its wind throw potential. Is it leaning? Are there other defects? And what has been going on in the site in the past? All of these factors we have to consider in what we're going to call the critical root zone. Now, Jim Clark and I are working on the second edition of Trees and Development book. And we would love for you to participate with information and your experiences. Please contact us if you would like to participate. What we need particularly is what's your experience with the critical root zone, and what is your experience with species construction tolerance. And in preparing this second edition, Jim has done a deep dive into these terms, tree protection zone and critical root zone. What's the difference? What do they mean? How do we use them? How do we determine what they are? And he has assembled a group of people, including everyone on our program today and Sharon Lilly, to talk about this subject. You know, how do we differentiate between these and how do we define them? And what we have come up with is that the tree protection zone protects the root, soil, trunk, and crown. It is defined by the arborist. It's related to what the development site is, and it is a line on a plan. The critical root zone, on the other hand, is a biological constraint, and it is the limit we can push the trees to still maintain good health and stability and structure. We don't know how to calculate this. We don't know what the biological constraints and limit is of an individual tree. We try to make judgments about that, but we don't have a way to apply some kind of formula to figure out what it is. Now, many of us work in areas where the government agency who has approval over projects defines what these terms mean. And we have to remember to adhere to those definitions when we are advising in those particular geographic regions. Quite often we see ordinances that don't use the term tree protection zone, they use the term critical root zone and have particular ways to define it. But from our standpoint, we do not think that it is something that can be calculated or defined because it is a biological constraint to how the tree performs. The most important thing, though, is that as the size of the tree protection zone approaches the critical root zone, the chances of the tree dying or falling over are greatly increased. So we don't want to push the tree so far in shrinking that tree protection zone that we get to the critical root zone. Now, in the real world, the tree protection zone needs to fit what is going to happen on the site and what can happen, and the construction and development constraints, as well as the governmental agency requirements. So I want to show you an example of this. This is a project I did years ago. This tree number 219 is this blue atlas cedar. It is a 31-inch diameter. It's in pretty good shape. I would call it mature. And we're going to figure out what our tree protection zone, actually the city requires that we define a tree protection zone for this tree. So if we go through the calculations in the table, we come up with a tree protection zone of 39 feet radius. So if I plot that on this plan, you can see that that tree protection zone overlaps a fair amount of construction. Well, it doesn't do us any good to define a tree protection zone where we know there's going to be excavation and root cutting and various impacts occur. It is critical that if we're going to do this work that we know how to read plans so that we can formulate a practical tree protection zone that will work in the framework of the development project. Once these plans are drawn, that is what's going to happen, and we can rarely change that. One of the things we were able to change for this tree is instead of having this slope continue under the tree, we asked the engineer to design a retaining wall to hold natural grade from here to the back of that retaining wall. In here, these solid lines are the future grade and the dashed lines are the existing grade. So we can see here that we are going to have some grading in here as the slope is laid back a bit. So where that solid line intersects with the existing grade is called the daylight line. And that's the limit of where the cut will occur. This line right here is the property line. So if we don't have any jurisdiction, we don't have any over what happens on this side of the tree. So defining a tree protection zone over there may be meaningless. Now then, what we can get based on this plan is about 20 feet. So from here to here is about 20 feet. So we have to be practical about defining this tree protection zone if we can't change anything about the design. So here is my definition of a practical tree protection zone for this tree. Note, it does not have a continuous radius. It has a weird shape that fits what is possible with the site. We have to have this tree protection zone a couple of feet behind the wall because excavation is going to occur a couple of feet behind the wall in order to construct the wall. We need to give space over here to allow the grading to meet natural grade. And we can't really go past the property line because we would be on somebody else's property. So this is what I came up with for the tree protection zone for this. It's an example of why you need to be able to read the plans, understand what's going to happen, and create a protection area that is possible in the real world. You can see that it is considerably smaller than what our optimum is. So part of my job is to figure out, is the tree able to tolerate that much encroachment into what we consider to be an optimum tree protection zone? I have been doing this work for 40 years, making my living primarily on doing tree preservation. And I have to say that while I have a whole lot more experience, I still cannot say with assurance whether this tree will tolerate that or not. So then the question is, well, do we recommend retaining it with these limitations? Or do we say remove the tree? By and large, unless I'm positive the tree isn't going to survive, I'm going to do the best I can to establish the tree protection zone and stick to it in the field. The bottom line is that protecting tree health and structural stability is our goal and our responsibility. We can't, normally, we can't build on sites without doing some damage to adjacent trees. We just have to figure out how to protect them as best we can. We start with the diameter standard height species age method. That's the table I showed you from the BMP. We need to understand how construction will impact that tree. We need to adjust the calculated tree protection zone to meet the tree conditions and site constraints. And we need to make sure we're following the rules of the government agency. If they make different definitions, if they have different definitions than the BMP has, we have to reconcile those in some way. I wish you luck in defining tree protection zones in your work. Now, Rich Hauer is up next, and he's going to discuss root cutting and its impact on health and stability. Thank you.
Hi, I'm Rich Hauer, and it's my pleasure to continue this session here today. I'll be talking about root pruning and the biological instability impacts that, and really what the literature has to tell us about this. So if we look at trees, it's more than just one factor. As you learned from Ryan and Tom and Nelda, that it's a really fascinating process to think about trees in construction, but it's also fascinating from the aspect of biology. And it's more than just usually one factor. Yes, certainly a truck could hit a tree and kill it, but usually it's multiple stress factors. As Jim Clark and Nelda Matheny, correctly pointed out 30 years ago, that's usually more than one thing that causes the decline and the death of a tree. It could be mechanical damage, it could be soil piling and you get oxygen limitations, it could be soil compaction, along with many other factors. Now, these factors combined together could end up killing a tree in a year, okay? And that's possible. Or typically what happens is it's a longer process. So Susan Day and Nelda Matheny, they discovered from the literature that basically up to maybe a decade it could take for, some sort of damage to a tree, whether it's stem damage or curb and sidewalk installation and getting top dye back, for all these things in the ramifications to occur from trees and construction damage. Now, it could take a century. In the case of this huge giant sequoia that failed from a storm a few years ago, and it was actually relatively recently, in the last, about 3 years ago, I do believe it failed. But this tree was damaged in the 1880s. So it took over 125 years before the impacts of major trunk wounding and the decay process. And giant sequoias are very decay resistant. And so, yes, it took well over a century for the ramifications of trees and construction damage to occur in the failure of this tree. Now, my focus here today is really on root systems, and more importantly, tongue-in-cheek, what's the worst that can happen? In this case, an electrical transformer that's been installed and roots were severed to, allow this to happen. What's the worst that could happen is certainly a tree that fails because of root damage and stability. And we'll get deeper into this. And this is a true story from the city of Milwaukee. Time frame, August of 1978, and over 400 trees came down following a windstorm. Now, Bob Skira, who was the city forester at the time, actually implemented a whole process, and I'll be talking a little bit about this work here today, that really talks about the impacts of trees in construction. In this case, they're severing tree roots to prevent sidewalk damage, which is certainly a good thing because homeowners pay for the repair of the sidewalks. But in the same process, the risk of a tree causing property damage or certainly personal injury, or at the minimum, the loss of a tree, is a really important thing to solve. Now, if you go into the literature, you could look at Virgil Howe. In the 1970s, he was a professor at Western Illinois University, and Virgil was looking at the impacts of construction and trees. And what Virgil discovered, that if you stay about 4 meters away from the tree on one side, and you're not damaging other areas of the tree, all things considered, the tree will survive the development process. Now, Fred Miller, he discovered at the University of Illinois, when some trenchers were being put in place to facilitate the installation of underground utilities, they found that trees that were 11 feet or further away survived the construction process. Now, myself, I've been involved with the city of Milwaukee and their trees and preservation research project for several decades now. And in our first paper, we discovered that if you stay about 5 to 6 feet or further away in a street tree setting, all things considered, the condition or the survival of the tree is no different than trees that were not construction zones. Now, all these ramifications, and Nelda correctly pointed out that it's more than just using an X factor, such as, stay 6 to 18 times the diameter away from the tree during construction processes. It's really more where a root's related, but we'll come back to this theme of, can you predict based on some of these X factors of how far away you are from the tree and things that could happen perhaps physiologically or from a stability perspective. Now, Susan Day has a really wonderful paper. It came out about a decade ago, and it was looking at the literature, in this case, tree height. Can you use tree height to predict where the maximum root system radius would be? And you look at this data, and what they found was, no, small trees, yes, but as trees get much larger, it becomes a lot more challenging to say that a 10 meter or 32 foot tall tree is going to be exactly, 6 meters or 18 meters away. It becomes quite variable. And there's a lot of factors that go into it. But if you are trying to use tree height to predict where the root system is, you're really rolling the dice. But if you use trunk diameter, which was really interesting, that there was a strong relationship, a curvilinear one at that, and it kind of, in some regards, makes sense. When you double the diameter of something that's going from 8 to 16 inches or 20 centimeters to 40 centimeters, you have a 4-fold increase of surface area. And so as tree roots expand, as the diameter of the tree doubles, the area that roots are going to be growing within is a 4-factor increase. So this data kind of makes sense to me from that perspective, but I was really surprised when I did see this graph. And it's a compilation of many people's research where they put into a normalized situation to make these comparisons. Now, interesting enough, if they only had small trees that were studied, you'd think this is just a strong linear relationship. But having a few studies that had larger trees, we get this curvilinear pattern. Now, what's the worst that could happen? If you're really curious about some of this work that we've done in the city of Milwaukee, you could send me an email. Just Google Hauer, UWSP, my institution, and you'll get my email. Email me and I'll send you a copy of this paper, or you could track me down ResearchGate and get a copy that way. Now, what we did discover, and this is a long-term study, it's been going on for 40 years now, that if you look at trees prior to construction occurring, there's no difference in the tree condition rating, which is kind of nice. But when the trees in construction program first occurred, yes, we could detect a difference in tree condition to the tune of about 5 to 6% lower condition rating for trees in construction areas. Now, this whole process of a trees in construction program has been developing over time. So now today, trees in construction zones are no different than trees in control areas where no construction occurred. If you look at tree survival, the same pattern. As the construction program evolved and they took steps to minimize damage to trees, when we went back and looked at this population in 2005, there was no difference in tree populations, whether they're control or construction trees. Today, interesting enough, trees in construction areas actually have a higher survivability rating. When we first got this piece of information, I thought, how do we goof up on our data collection? And actually what it ended up being was, when Milwaukee does work around trees now, they take great strides to minimize damage to root systems. Here's the old curb line, here's a tree root, here's the new curb line. So how they go about doing this is when they install these new infrastructure, such as curbs or sidewalks, they actually are shrinking streets by maybe a few centimeters. And I'll show you an example here in an upcoming slide. But at the end of the day, what are they gaining? More soil volume, more soil volume. This is really the factor. When you control for that, that explains why trees in construction zones are actually surviving at a higher rate. And this data shows it really well. If you do a logistic regression and you use odds ratios, and there's ways to how we develop this graph, but a tree growing in a 10-foot or a 300 centimeter tree lawn between curb and sidewalk compared to one in a 60 centimeter or a 2-foot sidewalk to curb tree lawn, they have about a 2 to 3 times higher odds of survival. So yes, soil volume is really an important factor here also in trees and construction. So this is the past practice in Milwaukee. When they'd remove a curb, there really wasn't strides taken on minimizing damage to root systems. This is the practice today. Excavators can do this. They're great people. They're very talented with machines. And if you said don't damage the tree roots, they can probably do that on a high probability. And today, when they put curbs back in, here's this little distance that this is where the old curb was, this is where the new curb is. And they've modified machines, by the way, as part of this whole process, where before they used to need about 30 centimeters of space. Now they only need about 5 centimeters between where the chute is for the the curb being installed, and the edge of the machine. Now, this will be on the exam later this week, so make sure to copy all this down. Now, in the paper that I mentioned earlier, Track Me Down, this is really the recipe for trees in construction and minimizing damage in the city of Milwaukee. So for a street tree situation, Milwaukee has a really good program to follow. Now, what does the science say actually about trees and construction? And so we're going to look at a few physiological things such as water potential. And so here's me at a young age doing some leaf water potential work with a Scholander pressure bond. Also me at a young age doing some work with a portable photosynthesis machine where you can measure gas exchange such as water loss through stomates, or also the carbon dioxide being taken up by a tree. And we can also look at whole tree failure or stem failure. So what does the science say here? So here's some work from Dr. Fini from Italy, and he looked at the impact of trees in construction where they put trenches that were a distance at 4.5 times the DBH. And they had things that there was no damage. There was one trench on one side of the tree, and there is a trench on both sides. And so over time, in this case, it was 4 years work. They found in one species that after 4 years, you could still detect the impact using a pre-dawn water potential. So this is the water potential at the morning before the sunlight comes up. In the case of Tilia europa, it was a 2-year time period where they could still detect differences. And then after that, the tree regained enough of the root system. And the lower the number, or the less negative, the less stress there is. The more negative the number, the more stress there is. Now, you could also look at water loss using that portable photosynthesis machine. And, you can maybe conclude that trees that have more damage, so on both sides here, the SD lines right here with the triangles going downward, that, yeah, they're losing less water, and maybe that's a good thing. Well, on the other hand, which is not good, is carbon dioxide uptake. So A just stands for assimilation of CO2, which is then part of the photosynthesis process. And what you can still detect here is with horse chestnut, for example, Hippocastanum, you still 4 years later are detecting some stress imposed upon the plant because of trenching. In the case of the Tilia, it was about a 2 to 3 year time period when it finally did recover. Now, you could also look at the bending moment, and what they found, even with both species 4 years later, that it was much easier to pull trees that had more severance, less severance and no severance. So again, both physiologically and from a pulling trees to failure perspective, you could detect the impacts of trees and construction damage to the root system. Some work from Dr. Benson and his colleagues, Andrew Kozer and Justin Morgenroth, they discovered that if you look at 3X versus 6, 9, 12, 15 versus trees that had no severance, so this was their study, and what they did was they went entirely around the tree with a trench. So you could think of this as kind of like a nursery transplanting perspective. In the United States, our standard is actually for transplanting trees is to be 12x away. As they found, if you look again using a pre-dawn water potential, that trees that had no severance had less stress relative to those that had the most severe case. And this was 90 days after the fact. They're still detecting some major impact at the pre-dawn water potential from severance. If you look at the cross-sectional root area, it probably doesn't surprise you as you're closer to the tree, you're going to sever more roots, and you can measure the cross-sectional area. So this would be, thinking of, the diameter of a tree, the basal area. In this case, it's just the root area. And if you compare 3X to 12X, it's about a threefold reduction in the amount of cross-sectional area that's removed. And what's kind of important about this, if you think about it, is this whole cross-sectional area. There's a strong relationship between cross-sectional area and everything beyond that. So the bigger the area, the more root loss. So it's a good way to measure this. They did another study. In this case, it was 3X to 12X. They looked at the same thing. It was this little 3X. 3X times 12X. There's 3 times less cross-sectional area lost with a less severe root severance treatment. Same thing, pre-dawn water potential, same finding. In this case, they went 440 days, so a little over a year that they investigated these trees, and they're still detecting stress in the most severe root severance situation. Now, this is some work that Dr. Tom Smiley did. And Tom and his colleagues, they severed tree roots right at the trunk line, 1X, 2X, 3X, 4X, and 5X away. And they're looking at really the impact of tree stability. And what they discovered is if you look at a species such as willow oak, you could get about 3x away. And statistically, it was no different compared to a tree that had no root severance that occurred. And the way they measured this is they just had a percentage of the original force needed. And as you got closer to the trunk, the less force that was actually needed to pull the tree to a 1 degree lean. And then they looked at red maple in another study, and they found you get maybe 2x up to the tree, and statistically it was no different. Or you could look at Virginia pine, and they're able to get 1x away and still statistically didn't have a difference compared to being further away. Now, this doesn't say the work of Dr. Smiley and colleagues is, boy, let's sever a tree 1x or 2 or 3x away. I would stick to industry standards in North America, which would suggest don't be within 5x from a tree stability perspective. Just at all times try to abide by that. But what they found is, depending on the species, Virginia pine, for example, has a deeper root system from a taproot perspective, and willow oak is a shallower root system. So the root system biology can have an impact on tree stability. But if you think back to the work of Dr. Feeney and Dr. Benson, what they discovered from a physiology perspective, yes, if you get this close, 3x, for example, that you're going to certainly detect for many years thereafter that you're going to have a physiological impact. Now, on the home stretch here, there's a lot of evidence from either a water potential basis, and again, these are some long-term studies, or from a gas exchange. This is a water loss through stomates or CO2 uptake through stomates, or whole tree failure, or pulling trees just partially to a 1 degree lean. That certainly staying 12 to 15x away from the tree or further is best interest for the health along with stability. So I'm going to turn it back over to my colleague Tom, and he'll take it from here on out.
Well, I'd like to wrap up this presentation talking a little bit more about standards and BMPs and how to use them to develop specifications and contracts. First off, we want to look at the scope of work, and this is outlined in the A300 Part 5 standard. The scope of work calls for the arborist and client to agree on which phases of construction the arborist will be involved with. And again, the more phases, the earlier we get started, generally the better the result at the end of the project. And we need to specify what is the arborist's involvement in each phase of construction. What is the location of the construction? Is it the entire site, or is it just a portion of it? Is it a single tree, or is it hundreds of acres? And then there needs to be a schedule of visits. How many times is the arborist going to visit the site? Will it be weekly, monthly, or at every phase? This needs to be determined, because this is going to cost or determine the cost of a lot of the project. And then what type, timing, and who is the recipient of the reports that will be generated from both the pre-construction tree assessment and the monitoring during construction. And if you need more assistance on writing specification, Annex B in the A300 standard goes through an example where they put in numbers. Again, these numbers aren't going to apply to every project, but they can give you an idea of where you need to fill in information. So that is all in the standard. So just as a summary, arborists should identify tree resources. This usually means a tree inventory, and make recommendations for tree removal, protection, or transplanting. They should determine the appropriate size of the tree protection zone. They should guide installation of TPZ barriers. They should monitor tree health and site conditions, and they need to be prepared to take action to protect the retained trees.
Traditional skills and modern techniques. Whatever language you speak, you have a world to offer every day. Climb with the eye USA.